Dr. Harish Tung, sir.
Good morning. Good morning. Good morning,
Good
ma'am.
morning, sir.
Uh,
Nice to see you and meet you here.
Thank you. Thank you so much,
Yes, sir.
ma'am, for
Yes.
giving me an opportunity to talk to this research fraternity.
Actually, it is opportunity to us, sir.
Actually,
Listen.
ma'am, it's always I have a passion of talking to researchers, and that is how because researchers are researchers.
Yeah, yeah.
Because they have what we can say in our time there were very few who were having certain innovative ideas, whereas nowadays almost everyone, those who are doing their undergraduation,
Yeah.
I mean post graduation, they may have that innovative ideas. So it's not only they are learning from us, but at the same time we are also learning from
Learning from
them.
them. Yes, sir. Very true. Very true. Very
It's
true,
a
sir.
process.
It's, it's a two-way process nowadays.
It's a two-way
Yes.
process by all
Yes.
means.
Welcome. Welcome, sir.
People may be accepting it or not, that is a different story, but it is always a
No, but
two-way.
it's true, sir. It's true.
Very true.
Yes, very true.
Shall we start, ma'am?
Yes, sir. My colleague, Miss Mrs. Varungase, is going to start, and then
Fine enough.
we will proceed. Yes.
Just give me an indication so I may start it off.
Yes, now just he is starting, sir.
Okay.
Yes,
Thank you
yes,
so much.
yes, yes.
Uh, Good morning, everyone. On behalf of YCMOU, I, Devayani Varungase, extend a warm welcome to all the participants, esteemed guests, and our distinguished speaker. It's a privilege to welcome you all to this SPSS software workshop, which is organized by Yashwantrao Chauhan Maharashtra Open
Yeah,
University,
please.
Professor Ram Takavle Research and Development Center. This center is dedicated to
Please stop.
promoting research activities and helping scholars and faculty members enhance their research skills through workshops, interactive sessions, and expert-led lecture series. In today's rapidly evolving academic landscape, the research holds a pivotal place, and workshops like this are vital in empowering scholars and educators with the skills and insights to excel in their endeavors. We are confident that this workshop will prove to be remarkable learning experience to everyone. To commence with the workshop, let us first invite the dynamic and visionary leader of this initiative, Emeritus Professor Kavita Salunke Ma'am, Director of Professor Ram Takavle Research and Development Center, to deliver the preamble for today's event. Kavita Ma'am?
Yes, 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 yes. Good morning, Dr. Harish, sir, and
Good morning, ma'am.
all my dear friends. Uh, Today we are here for the use of statistical tool SPSS workshop. And friends, we have conducted one research workshop in last month, uh, 8 days workshop. And in that workshop, we have covered so many concepts which are useful for research, uh, like referencing style and plagiarism, components of research paper, characteristics and types of research, citation, and how to publish the paper in international journal, mechanism of writing paper, ethics of research, use of knowledge research center in academic writing, and all these things. But the topic which is very useful for each and every researcher for data analysis, which save our time. That is use of statistical SPSS. And for that, today we have Harish Tank sir, who is going to deliver a lecture and as well as some hands-on experiences also in this workshop. And this workshop is our follow-up activity, which is we have conducted earlier follow-up activities. So this is first one, and I am happy to welcome to you all today for this workshop. Thank you.
Thank you so much.
Yes. And our Vice Chancellor, he is busy in submitting now, but he is going to guide us at 1 p.m.
Okay.
After the when our workshop will finish after 3 hours, he will join and give us guidance. Thank you. Thank you.
Thank you, ma'am, for setting the tone for this workshop and for sharing the inspiring objective of today's event. Now, it's my privilege to introduce our today's esteemed guest speaker, Dr. Harish Tang, which has joined us from Rajkot, Gujarat, to enrich this workshop with his vast knowledge and experience. Sir is the head of the statistics department and associate professor at Sri Sadgurudev Sri Ranchod Das Ji Mahila Home Science and led MJ Kundalia Mahila Commerce College, Rajkot, India. With a PhD in statistics, over 25 years of teaching experience, Dr. Harish has made substantial contribution to academia as well as in research. His areas of expertise include Bayesian inference, cryptography, data security, and education policy. He has supervised numerous PhD scholars, analyzed extensive data set, and authored more than 50 textbooks on subjects ranging from business mathematics to research methodology. Sir's research in reliability theory and statistical modeling and education innovation has received several awards, including prestigious Rashtriya Shiksha Gaurav Puraskar. He also honored with Young Scientist Award from the Indian Science Congress Association in 1998, 2000, and in 2001. In addition, this leadership in fostering academia and industry collaboration has been recognized, including serving as the chairman of CII Western Gujarat Zonal Council, promoting skill development initiative. Sir's publication in High Impact Journal and his leadership in fostering academia industry collaborations highlights his dedication to excellence. We are truly fortunate to have Dr. Harish sir with us today to share his expertise on research methodology and SPSS for data analysis. Now I kindly request to Dr. Harish sir to begin with the session. Thank you, sir.
Thank you so much, Devangi ma'am. Uh, uh, I express my gratitude to the esteemed dignitaries, Vice Chancellor Professor Sanjeev ji, Pro Vice Chancellor Jagendra Singh ji, Registrar Dilip Bharad ji, and of course, the Director Kavita ma'am. Let me, you can say, combine everything. Whatever Devangi said, fundamentally, I am basically a teacher. And that introduction is probably suffice everything, I suppose. Today, we are focusing much on SPSS, and I have worked on it, so I know a bit about it. And it is always my passion to talk to all the researchers. It's you can say, uh, bilateral delivery. I'm trying to explain how this session is going to happen. It would be more on an interactive mode. It would not be in a form of a one-way communication. The basic idea is very clear that something which is being delivered, and if you have any question related to it, we'll be interacting it, right? And at the end of the day, I mean, at the end of the session, we will have a open house, and whatever questions you have, I'll try to convince, and I'll try to address all the questions which you have as far as SPSS and research methodology is concerned. I have designed this particular course exclusively to this institute, uh, Professor Ram Takwale Research and Development Center and School of Online Learning in two parts. The first part is before shifting to a statistical software, SPSS, one must have some ground of statistics, or you can say some part of research methodology. So my intention is, first of all, let us focus a bit on it, and then after we'll be switching it over to an SPSS. SPSS is a software which one have to operate it as you operate Word, Excel, PowerPoint, and I'm not sure, but almost many of us may haven't gone through any of the structured form of a training for using Word, Excel, PowerPoint. Still, we are using it extensively. Similarly, this SPSS can be used. It is little different in a way that it addresses statistical analysis. That's it. There is no other. So we don't have to much worry about how this software works. Basic and the fundamental thing is we should be clear enough what we want to do, what we are expecting as an output. For a moment, let us suppose any of the statistical tool is used. This can be done with SPSS with a single click. The only important thing here is before a clicking a key, we should be very clear about what we want, and the output which is provided by SPSS, the interpretation of that output, that is the key. In short, my intention is saying about it is simple, that at an entry level, we should be very clear while feeding the data, and at an exit level, we should be very clear about what exactly the interpretation of our outputs are. It is that simple, right? Okay. May I have a presentation now?
Should I share, sir?
Yes, please, if you can, would be better.
Is it visible, sir?
Yeah.
Okay.
Can we run it?
Yes. No, sir. Actually, it's a PDF.
Okay, fine. I'll be doing it. No worries. Just a minute. Give me a second. Is it perfect? I mean, is it viewable?
Yes, sir.
Okay, fine enough. Thank you, ma'am. And
Yes.
here we start. I must start with a very well-known quote that statistical thinking will one day be as necessary for efficient citizenship as the ability to read and write. But it would be of that importance. In the today's world where this blooming of data, so almost everywhere in every sphere of life, you need to decide something, you need to take a decision. Decisions are generally more or less based on data. In every day, means every now and then, or you can say in every sphere of life, it is very much needed to take a decision, and it is as same as of ability to read and write. And I found it very interesting that this is very true in today's world, right? Okay. Now, the first word which we should focus on, it is research. Actually, if we just focus on the word research, it combines two words. One is re and second is search. Re means again, once again, you can say. Whereas search means exploring, observing, analytically, interpreting, or validating, right? Or any of this thing may happen. Okay, when I say research, means something is already being searched and we are trying to explore it, observe it,
Right.
analyze it, interpreting it, or validating it, right? So this is how the word research comes in picture. So before starting any of the research, a researcher should be well versed of searching. Once he is likely to search whatever his or her intention or topic is, just go through it, just try to explore it, try to observe the problem among those things. Once you observe, then after try to analyze it, then after interpretation, and then after validation. The whole means integrating all this point ultimately is being used as research. So that is how we should be very much sure about that research. Try to depart it. First thing is to be done is search it, means go deep inside your topic, try to get the problem inside it or a question inside it, and then after whatever things are available in the society or in a market or in a portals, just review it, learn it, understand it, and if you find there is some limitation, means your basic approach and the thing which is documented, they don't go in line to line, then you may have to think of what are the differences and how you'll be able to get that difference documented. This is what the process of a research is. I hope this makes us very clear that what research is, right? Okay. Uh, the key features of a research is it should be systematic and organized. Objective should be very much clear about it. It should be replicable and it should have an innovative idea. That is what I say. By putting it in words, we can put it this way, right? Okay. Now, I am trying to put all these things in statistical form. Research as a whole, non-statistical definition or a non-statistical thing was, as we discussed, but as a statistician or how statistics views this research, it is little different, right? So I am trying to give some examples so you may get it clear that how statistic thinks of research. Suppose a scientist want to understand whether a specific herbal extract can exhibit. Okay. First of all, what we need to do is we have to, just a minute, we have to, naturally, in a herbal extract, there would be some bacteria. Naturally, the question which you are, which comes in your mind, and you feel like this may happen, or this may not happen. Naturally, this question is to be formed in statistical form, and that question is tagged as hypothesis. And the whole process of it is called formulating a hypothesis. Generally, these hypotheses are of a two different kind. One is called H naught, means H0, and another one is called an alternative hypothesis, which is called H1, which is generally a simple complementary of what is there in H naught. That will come at a later stage, what exactly it is happening. Okay, so the formulating hypothesis, I'm using a statistical word, hypothesis. What exactly it is? Hypothesis is nothing but a statement. A statement which you feel like this is supposed to happen. Okay, when you feel like that this is something which is going to happen, it doesn't have any evidence. The only evidence with you is your observation or non-statistical or non-mathematical evidences are there. To put it on a documented form and to make it more authentic, all these statements are to be tested. It is as simple as that. Okay. To test this hypothesis, that is where statistics comes in picture and a tool. SPSS is a software which helps us in testing the hypothesis and which is the base, or you can say the core thing related to any of the statistical analysis, right? Okay, coming to the summarizing it, research. Now, I think the whole part is very clear that what exactly the research is. Uh, It involves experimentation and all 4 points like validation, experimentation, observation, and all these things integrates, and the whole thing becomes a part of a research. Okay. Everyone may have used this word in life many a times. Data, almost every day we are using it. Second one is information. Third one is knowledge. Fourth one is wisdom. As a layman, I'm not talking right now with the capacity of a statistician. As a layman, what you think about data, what you think about information, what you think about knowledge or wisdom, we are trying to understand it. Data. Data simply means that in a raw form of a data, you can say raw form of data means it is very simple that it is an unprocessed facts, figures, that symbolizes data. For a moment, let us suppose right now how many researchers are inside this workshop. That is the data. What is the age of all the participants? That can be the data. In short, any numerics which is an unprocessed, that can be a data. Okay. Not only the numerics, even the facts, figures, symbols, all these are called data. If you put it in a single line, any unorganized and unprocessed numerics, facts, or figures can be treated as data. That is what the definition of a data is. Okay, data can be of a two different types. One is quantitative data and second is qualitative data. These are very simple. I'm trying to make you understand by taking your day-to-day life examples. When I say qualitative data and quantitative data, as the word suggests itself, for a moment, let us suppose quantitative data. What do you mean by quantitative data? Quantity. Generally, quantity. What you understand with the word quantity? Anything which is measured. Measurable thing is tagged as quantity. For a moment, let us suppose temperature of a city, height, weight. I'm taking a very normal, or you can say even percentage of a student given in a mark sheet. All these are measurable. So all the things which are measurable is called quantitative, means numbers. Is it perfectly okay? Fine. The another thing is quantitative. Second word is qualitative. Qualitative. Qualitative data means which gives certain words about quality. Quality means it is very simple, that which is not measurable. So naturally, quantitative it is measurable, qualitative it is not measurable. The thing which you can say about it is two things. Is it present or it is not? It is that simple. For a moment, let us suppose we talk about honesty, honesty of a person. What you can say about it? Only one thing, whether he might be honest or he may not be. There is nothing like in between. Okay, can you measure honesty? This is 70% honest, this is 80% honest. No, it's not so. So this is how this quantity, qualitative and quantitative things differs. Qualitative means it is present or not. The only thing which we can describe about it is. Whereas if we think about quantitative, that can be the numbers and that can be measured. This is what the process is, right? Okay. Uh, for a moment, let us suppose there is a classroom. In a classroom, it's a co-ed college or you can co-ed university department. Someone comes in a classroom and he wants to classify the whole classroom. And while coming inside, he says that all the male members be on the left hand side, all the female members be on the right hand side. Look, gender becomes a variable by which you are classifying the whole class. Okay. Similarly, some another person comes in a classroom in the next lecture and he says that all the person who have wear spect may be on left hand side, those who haven't wear a spect may be on right hand side. Look, he is classifying the same classroom, classifying the same classroom with a different variable, with a different attitude. So similarly, your data on the site of measurement, if we classify it, then one can classify it as quantitative and qualitative, right? Okay, this was the classification of data. This is what the data is. Okay, the next thing comes in picture is information. Okay, where it is coming from? Naturally, all the information is coming from data only. Data, if you just process your data and if you answer certain questions like what, who, where, and when, whatever answer comes, that answer is tagged as information. For a moment, let us suppose we have collected the data of a city, temperature of a city. There might be many numerics. From 8 to 9, it may have another temperature. 9 to 10, it may have another. So it would be a sort of a liquid type of a data. Okay. On the basis of this data, I want to conclude and I just want to say an average temperature, then I have to give a number. And if I state a statement like the average temperature is 30 centigrade, so at that, this average temperature, 30 centigrade, that becomes information. So try to understand it. Information is always based on certain data, right? The next step, after gathering this information, the next thing comes is knowledge. How this information gets converted to knowledge. Knowledge is understanding, awareness, or you can say if you can view certain pattern, if you can recognize it, and that recognition of the pattern and the statement related to it. If you just ask a question, how, or why? If you answer this question for data and information, whatever you state, it becomes knowledge. For a moment, based on a weekly temperature, data, and knowledge of a weather pattern, predicting it that it might rain in coming week or in coming days, temperatures will go down. Look, here no numerics are there, but it is a conclusion observing certain information which is based on data, so it became knowledge. After the word knowledge, the next thing comes is wisdom. That is the ultimate forum. On the basis of knowledge, if we just put it on a longer attitude, means focus on long-term implementation, and if you make a statement related it with, then it becomes wisdom, right? If you just take the same example of a temperature, then after an average temperature, then after it may rain in coming weeks, and now instead of focusing on day or weeks, if we can state something like advising a farmer that require less water because of a rainy season based on historical data and its pattern, whatever claim you make, that becomes wisdom, right? So this is how all this data can be thought of. I tried to put it in a tabulated form also, but things are similar to which we have explained it right now, right? Shall I go ahead? Okay. These are some real world examples. Raw data, 100 cars from 8 to 9, 200 cars from 9 to 10 a.m. So naturally, it's a simple numerics. Simple numerics represents data. Some information can be fetched out of this data. What it is? That the peak traffic hours are 9 to 10. So that becomes information. When you say that the morning peak is due to school and office timing, that becomes knowledge. And suggesting diversions and staggered schools and office hours to reduce traffic jams, that becomes wisdom. Is it clear now? I hope it is clear what this data says. Okay. Once one understands this data, the next very important thing comes in picture is hypothesis. That here our statistical journey starts. You should be very clear about this thing before analyzing any of the data set. Hypothesis, as we have said it earlier, that hypothesis is nothing but a statement to be tested. Naturally, that statement, since it is the first statement which is there in our mind, it is called H naught. And if it is not going to happen, means exactly complementary of it, it is known as an alternative hypothesis, which is called H1. Okay. What may happen while taking a decision? Decision in the sense whether to accept the hypothesis or reject the hypothesis. These are the two ways of implementation. Okay. Two way of hypothesis, if you just put it on a R2 plan and means in a two-dimensional form, the picture may look something like this. Hypothesis is true and it is being accepted. Hypothesis is true, it has been rejected. Hypothesis is false even though it is being accepted. And the fourth thing can be hypothesis is false and it is being rejected. Means any of these four different criteria, one criteria may come in picture or in existence. Okay. If the hypothesis is true and if we accept it, then it is the right decision. Just focus on the first, this green color area. Hypothesis is true and it is being accepted, so naturally that becomes a right decision. You don't have to much worry about it. If the hypothesis is false and it is being rejected, naturally a false hypothesis to be rejected becomes a right decision. So there would not be any issue in it. Only the problem occurs when your hypothesis is true. Instead of accepting it, we reject it. That means the first right hand side corner, upper side corner, and that is called type 1 error. When hypothesis is true, it is being rejected, is called type 1 error in statistics. Okay. The another error can be hypothesis is false, but still we accept it. That gives us a type 2 error. Okay. So type 1 error is tagged as a false positive, whereas type 2 error is tagged as false negative. What we are into right now is there can be two errors, and a two-way one can take a right decision. Two errors, one is type 1 error, second is type 2 error. Hypothesis is true, it is being rejected, that means it is false positive. And type 2 error, which is hypothesis is false and it is being accepted, that means it is a false negative. Okay. The only first question comes in mind is which one of these two error is more serious? That is where statistics comes in picture, or you can say any of the statistical software. Okay, before focusing on which one of these two error is more serious, we need to focus a little bit on what exactly this type 1 error and type 2 error is. Okay. By definition, it is called H naught. It may be said as false positive. That means error. Error means type 1 error. Okay. The impact of it, or you can say effect of it. We assume there is an effect or a difference when there is none. Generally, in statistics, it is being denoted as alpha. Alpha is a notation. And this alpha, while testing, in testing a hypothesis, always this alpha is predefined. Predefined means generally we call it level of significance. Generally it can be of any three. It can be 1%, it can be 5%, it can be 10%. Okay. Try to understand it. What do you mean by 5% level of significance? It is type 1 error. Okay. As I'm coming back to this, type 1 error means hypothesis is true, even though we have rejected it. Hypothesis is true, even though we have rejected it. Okay. And now we say that level of significance alpha is 5% or alpha is 0.05. What do you mean by this? It is very simple that if you talk in a percentage form, that if you take 100 decisions, of which you can make this type 1 error 5 times, and we are fixing it. That is how that level of significance is 5%, or you can say alpha is 0.05. Probably, I'm not sure about it, but one should understand this level of significance means it is a percentage or a numeric value. How many times there is a possibility of type 1 error. That is what level of significance is. It is as simple as that, right? Okay. Let us suppose a court trial is going on. Our H note is the accused is innocent. Okay. If an innocent person is convicted, that means rejection of true null hypothesis, that you can say it is a type 1 error in a real life situation. The person who is innocent, even though he is being convicted on the basis of some whatever maybe the documentation would be, on the basis of those documentation, if he or she is being convicted, then we are making type 1 error. This is the best example of type 1 error, right? Okay, coming to type 2 error. Type 2 error, I'm coming back to this graphical part. Type 2 error means a false hypothesis is there and we are accepting it. False thing to be accepted, that means it is false negative. I'm coming back to this part. Okay. When we fail to reject null hypothesis, where actually it is false, fail to reject, both of them are negative statements. Failing is negative, rejecting means negative. Two negative becomes positive. That means we are accepting null hypothesis when it is false. Simple? Okay. So it is called false negative. Again, these are the two negative statements. False is a negative statement and negative itself is a negative statement. Two negative becomes positive. That means accepting the null hypothesis where actually it is false. It should not be. This type 2 error, as type 1 error is being denoted with alpha, here type 2 error is being denoted with beta. One more statistical tool is there, beta. Beta means it is the level of significance you can say, but beta is actually the notation for type 2 error. Okay. Type 2 error means you can make this mistake in beta. Beta can be any numeric value. It can be 0.05, 0.01, or it can be 0.1 even. Okay. It would be as same as of that alpha. Okay. Then here one more tool is there. It is called power of a test. Power of a test is if one cannot, if one doesn't make this error, the total probability is 1. The percentage, the highest percentage can be 100. It is as simple as that. So 1 minus beta will give you the power of the test. So that is again one of the tool how we can check it, the power of a test. Okay. Now we try to understand it in terms of our the same example. Our H naught is accused is innocent. If a guilty is acquitted, means failure to reject a false null hypothesis, it is type 2 error. I think I could make the difference of both the type 1 and type 2 errors. I personally feel that until and unless these are the things which are not clear in your mind, then it may cause certain issues at a later stage in your research area. That is why I'm putting more emphasis on all this very routine kind of a words, but one should use it and one should you can say, rely on it if you are clear about what exactly it is. Okay. As I said, which one of these two is more serious? What you think about it? Again, it is based on case study. Based on case study, in certain cases, type 1 error is more serious. In certain case, type 2 error is more serious. But if we just take a pharmaceutical company for a moment, if we just take any of the pharmaceutical company, then testing the effectiveness of a tablet, can anyone say that which one of these two is more dangerous or more serious? Let us suppose a tablet is poisonous. Now think of it a type 1 error and type 2 error. Look, I'm coming back to this to try to make it very clear. The tablet is poisonous. That is what your H naught is. Tablet is poisonous and you accept it that it is poisonous, then the decision is perfect, right? Okay. Tablet is poisonous, you reject the hypothesis. Reject the hypothesis means you feel like, no, no, it is not poisonous. Look, it is poisonous, but you deny to accept it. It becomes type 1 error. Okay. Hypothesis is false. Actually, the tablet is not poisonous. And we are accepting it. It becomes type 2 error. Not poisonous. We are rejecting it. It becomes type 2 error. Coming back to our part, which one of these two error is more serious? Why we need to answer this question? It is just because of that both this error works on a different direction. If we try to reduce type 1 error in any of the statistical data, it may increase, type 2 error will be increased much more. If you just try to control type 2 error, type 1 error will be increasing like anything. So naturally, you have to balance it. Okay, before balancing which part is to be balanced, you need to think of which one of these two is more harmful or you can say more serious. I am taking an example. Everyone might be good with history. There is one case in our history, Dushyant and Sakuntala, if you might be knowing it or not. Uh, Dushyant was a king. He went to jungle and he was having his vacation in jungle, and he met Sakuntala there. Okay, and they married. Then after this Dushyant, who was a king, he came back to his state, and he forgot that he married Sakuntala. On the basis of this example, I tried to make a hypothesis to make it more understandable. This has nothing to do with hypothesis or a statistical analysis because it itself is an history and we don't need to conclude any of the, we don't need to test anything out of it. But to make it the clarity about what is hypothesis and which one of these two is more dangerous or serious, I have taken one example. It has nothing to do directly with this example, right? Okay. Let us suppose H naught means null hypothesis. Sakuntala is not Dushyant's wife. That can be one of the way. Okay. Then what can be the alternate? Alternate is simply a complement of the first one. Sakuntala is Dushyant's wife. That can be an alternative hypothesis. Is it perfect? This is a formulation of hypothesis. This process is called formulation of hypothesis. Okay. Once you formulate the hypothesis, the next thing comes in picture is type 1 error. One has to think of type 1 error. Okay, what is type 1 error? Rejecting a true null hypothesis is called type 1 error. Okay. What is the reaction? Dushyant, means King Dushyant, rejects Sakuntala's claim of being his wife. That is type 1 error. Whereas Sakuntala is in fact his wife. Means H0 is true, but Dushyant is not accepting it. That is how that is being treated in statistics as type 1 error. Clear? What can be the consequences of it? Sakuntala may suffer humiliation, rejection, delays of, this rejection delays their reunion and creates some havoc for both of them. That can be the output of type 1 error. Okay. Now let us think at the other part of this coin. Type 2 error. Failing to reject a false null hypothesis. What can be the action? Dushyant might have accepted that Sakuntala is his wife, whereas she is not. Whereas she is not. This can be a type 2 error. And another woman falsely claimed to be his wife, and Dushyant, the king Dushyant, accepted it. So it becomes a case of type 2 error. I hope now the things are clear about what is type 1 and type 2 error. Right? Dushyant rejects the truth of Sakuntala that she is his wife. That is type 1 error. And in another case, it becomes type 2 error. Which error is more serious? In this story, type 1 error is more serious. Type 2 error is serious, but it is not that serious. But this might not be the case every time. If you just take different examples, then things might be different in any of the case. Generally, type 2 errors are more serious. Generally, it depends on case to case. But generally, type 2 errors are treated as more serious error. Okay. I hope all these things are clear now. What is type 1 and type 2 error? Now, our intention is to focus on testing the hypothesis, right? Okay, there is a predefined structure that these are the steps to be followed while testing a hypothesis. As we have seen it in the first before half an hour, that first thing is to be done is make a statement of hypothesis. Naturally, it consists two statements. One is H naught and second is H1. What is the difference of H naught and H1? H naught is a statement, whatever there is in your mind. And its complementary, its absolute complement becomes the H1, or you can say alternate hypothesis. So that is called the statement of hypothesis, or the state the hypothesis. Okay. Once this hypothesis is stated, the second thing, the most important thing is test statistics. Whenever the word comes, test statistics, which is some formula, you can say. Right now, just take it as a formula. A specific formula is there. Okay. You have to pass certain data from one side and you will get certain value on right hand side, right? Okay. The intention is very simple. Before of that, there are few things to be taken care of. in statistics where this data is coming from. Where this data is coming from means, if you just say it in a statistical way, that what is the probability distribution of data? Here lies the originality, or you can say here lies the problem. Okay, problem in the sense, one may think of that probability distribution. We have to state something about probability distribution for sure. Okay, if we just need to think about probability distribution, there is one law. That law is called law of large number. Okay, this law of large numbers says that if you collect a huge format of a data, huge format means numbers are collected in a huge format, then you can take an assumption that it is coming from normal distribution. This is what they call it law of large. Okay, fine enough. If it is not in a large number, then they may have different probability distribution. It can be discrete distribution, it can be continuous. Means I'm not going deep inside it, because otherwise all three of us will be focused on this part only. So I'm not much focusing on it. The simple thing is it may have a different probability distribution. But there is one more law, and that law says that almost, whether it is a discrete or a continuous type of a probability distribution, ultimately it follows normal distribution. That makes us little happy. Little happy in the sense that whether whatever may be the distribution of data is, ultimately if it follows a normal distribution, that then we can take an assumption that all the data set which are coming is from normal distribution. Fine enough. Our problem is over. Problem is over in the sense, we will take an assumption that all the data is coming from normal distribution, and we'll try to gather more data, more in sense a huge number of data. Fine enough. The next thing is very important, is specify level of significance. Okay, specifying level of significance means, again, the word level of significance. What is that? It is alpha. Alpha, which we have just focused on it, alpha is 0.05. 0.05 means alpha is 5%. So we are fixing type 1 error before testing any of the things. We are fixing it in the sense that allowed limit of being wrong and as type 1 error, which is being fixed at 5%. Among 100 decisions, you are allowed to make 5 decisions wrong, that too of a type 1 error. Fine enough. Okay, what will happen next? If you fix it, now there would be a decision rule. There would be a decision rule which is being prefixed. Okay, collect the data and calculate this test statistics and all. On the basis of this test statistic, make a statistical decision. And on the basis of this mathematical or a statistical decision, you can make that. Now it is a sort of a wisdom now. We have started it from data, and it leads us to wisdom, right? Okay. The next thing, state the hypothesis. And again, whatever we have explained it, I am giving you some of the example traits. Okay, formulate a null hypothesis and an alternative hypothesis. As I said, null hypothesis is a statement, and exactly complementary to that statement becomes H1. You can say an alternate hypothesis. Let us suppose of a classroom, there are number of students. and the mean test score. We are gathering the information about their test score. And let us suppose that mean test score is 50. This becomes a statement. We want to test it. Okay, then it becomes H naught. H naught means null hypothesis. That is what they call it. And exactly opposite to that means complement to that, it becomes, if we say that the mean test score of a student is 50, exact complementary statement to that is the mean test score of student is not 50. It is absolutely a complementary thing. That becomes alternate hypothesis. Okay, look, in this case, test score is 50 and test score is not 50. It is very simple. Okay, not 50. Again, when one says uh, mu, let us suppose it is mean. Mu is 50 and mu is not 50. But when I say mu is not 50, it consists two statements. It can be less than 50. It can be greater than 50. Are you getting my point? In short, when I say not equal to means it may have two dimensions. One, it can be less than or it can be greater than. Okay, so the first statement is mean score mu is 50. So your H naught can be, you can frame it in a different way. H1 can be mu is less than 50, can again be H1. Mu is greater than 50, can again be H1. Okay, then what is the difference? Okay, coming back to this drawing. Look, the graph which is shown in a one-tailed test. When I say mu is greater than 50, which comes on the right-hand side of a graph, means we are addressing this shaded area. We are not focusing on any other thing which is on left side of this shaded area. I'm talking about one tail, right? So naturally we are focusing on one of the tail. So that test is called one-tailed test. Your data set is skewed on right hand side. So it becomes one-tailed test. Okay, for a moment, let us suppose your H naught is mean score is 50 and H1 is mean score is not 50. Look, in that case, you have integrated both the things in H1, that it can be less than, it can be greater than. So naturally, you are focusing on, again, just focus on this two-tailed. Two-tailed in sense, two-tailed. It can be less than, it can be greater than, but both the things are to be taken care of. So both the tails are important. Since both the tails are important, so that test is called two-tailed test. Right? So this is how a formulation of H naught and H1 is. One-tailed and two-tailed test. This is how they differ in nature. Okay. Select a significance level. As I said it 5%, that means you are allowed to take 5 faulty decisions are allowed among 100 decisions. You are fixing it at a level, and that is why it is called level of significance. That means it is simply a numeric value of type 1 error, which you are fixing it right from the beginning before testing. Before you start testing, you are fixing it to 5%. Right? Okay. The third thing is choose the appropriate test statistics. Okay. This is the core area. Which test is to be applied, that we have to fix it, that we have to take a decision on the basis of this. Appropriate test statistics. Generally, your data set can be, we are coming to that, even our data set can be categorical or it can be numerical. Accordance to SPSS, we will be explaining it in a much deeper way in coming slides. Data type can be categorical or it can be numerical. Fine enough. It depends on sample size. Fine enough. And the third thing which depends upon is the distribution of data set. Is it normal? It is non-normal. Non-normal in the sense it is coming from exponential, it is coming from any of the discrete distribution, whatever may be the distribution. As I said it earlier, that you can take it as that ultimately all the distribution follows normal distribution, so there would not be any issue. We can take an assumption that it is normally distributed. Okay, what are the tests? You may have gone through all these words: t-test, z-test, chi-square test, ANOVA. ANOVA means this analysis of variance, which is a short form of analysis of variance, which is called ANOVA. Okay, and generally this ANOVA will give you F value. F means it is F test. You can, this can be treated as F test bolo, ANOVA bolo, analysis of variance bolo. All these things are same. Okay, so these are the name of all this appropriate test statistics. And there are certain rules and regulation when and which test is to be used, right? Okay. Defining the decision rule. This is what we have seen. In SPSS, whenever we test something, whatever may be the output, in output there is one uh, uh, value is there, and that value is called P value. Generally, we take decision on this P value. For a moment, let us suppose our alpha is 5% level of significance and two-tailed test is there. Then our H naught in the output, if our P value is less than level of significance, which is 5%, 0.05, then we have to reject null hypothesis. This is a thumb rule. If our P value is less than level of significance, reject H naught. Okay, when I say reject H naught, what do you mean by that? That means accept H1. Naturally, the byproduct is accepting alternative hypothesis. It is as simple as that, right? Okay. Now, this can be the decision. Okay. What if your P value is greater than level of significance? Naturally, that simply indicates that accept H naught. While accepting H naught, simply the byproduct is rejecting alternative hypothesis. This becomes the way of taking a decision. Okay. Now collect the data, use the test statistics, use any of this Z, T, or chi-square, uh, even this ANOVA, all these things, anything, any of these things can be evaluated. And ultimately, in any of this test is used, you will always get a p value. And the thumb rule remains same. If your p value is less than level of significance, reject H naught. If your p value is greater than or equal to the level of significance, accept. That becomes a thumb rule. Okay. Make a decision. If p value is less than or equal to alpha, alpha means level of significance, reject H naught. Greater than alpha, fail to reject H naught. That means accept H1. Right? This becomes a criteria of making a decision. On the basis of this criteria, if you just put it in your terms, right now what we have talked about was a statistical term. If you put it in our terms means again mean, test, score. We are trying to conclude something about mean, test, score. So naturally, it becomes a conclusion and it is called an interpretation. Means to fix it up in our own way, in our own problem, if you just try to convert it in our language or in our problem language, then it becomes a conclusion or you can say an interpretation. This is what the steps are: stating the hypothesis, fixing the level of significance, choosing the right test statistic, defining a decision rule, collecting the data, making a decision, and drawing a conclusion. These are the process of testing, right? Okay, let me ask you one question, if anyone can answer it. Why this testing is needed? Why we need testing? Can anyone? Okay, we are not wasting much of our time. Let me tell you one thing. Why this testing is needed? Okay, it's very simple. For a moment, let us suppose among many of you are focusing on a research project, and for a moment, let us suppose in Maharashtra, you want to make a statement uh, about any of the industry. If this industry is you can say it is a good industry and it is increasing its revenue in 45% per annum, something like that. If you want to make a sort of a statement, how you'll be making it? When you make a statement related to any of the industry of Maharashtra, or particular you can say of Nasik, let us talk to your hometown, then how you will be making a statement, how you will be forming that statement. Formulation of statement is not a big deal. This is the industry which is rapidly growing, and that to this much percentage. That is what you want to claim. Okay. If you just want to claim, naturally, you have to first of all gather the data. When the industry which are at Nasik try to collect data from each of the industry, and then after analyze it, and then after you'll be able to give some example, give some statement. Every time this is not possible. If it is Nasik, you may be able to go to each of the industry factory and gather the data. If I just want to make a statement for Maharashtra, how you'll be doing it? You may have to go to each of the industry and get the data. If I just want to make a statement pan India, then each of the each of the factory outlets to be taken care of, you have to visit it and gather the data. This is not possible every time. So what you are likely to do? Naturally, on the basis of a research design, we'll be collecting data from some of the outlets of factory. Okay. Some of the outlets of a factory, we will be analyzing it, we will be defining, passing through some of the mean and variances and all statistical terms. Now, our intention is you may get your mean of your sample as 50 for a moment. I'm taking one example, numerical example. Let us suppose it is 50. This 50 is a mean of your sample. You want to state that this sample mean, whatever it comes, let us suppose it is 50, the population mean will be 50 only. That is what you want to claim. Okay. Naturally, you received or you get 50 as a sample mean, and you want to claim that your population mean is 50. Can you do it without any evidence? No. You cannot make any statement for population on the basis of sample. Okay. Directly one cannot do it. If you pass through certain process, you will be able to make a statement for population on the basis of sample. Okay. As I said, passing through certain process. What that process is? That process is testing. If you test, if your data passes through statistical test, and if you get uh, acceptance or a rejection of hypothesis, on that basis you may be able to make a concluding remarks for population, even you may haven't taken data of the whole population. On the basis of sample, you will be able to conclude, or you may be able to say something about population. This can only be done if your data of a sample is being passed through certain process. That certain process is testing. Is it clear why this testing is needed? Testing, which test is to be used, that is a different story, which we are not right now focusing on that part. Clear? Okay, coming to the next part. One more statistical tool which is being, you might have gone through, which is correlation and regression. This terms may have coined many a times if you just go through it. Okay, correlation and regression, these are the two statistical technique which we talk about until and right now, till the last slide, we were talking about single variable. We were talking about single variable. When I use a word, means this slide is on, we talked about correlation and regression. That simply indicates now our focus is on more than one variable. That is the primary difference. When I call correlation, when I call regression, that means now we are talking about more than one variable. It can be two or more than two even. Okay, focusing on two variables. Correlation, as the name suggests, we are talking about relationship. How these two variables are related, that that numeric value is tagged as correlation. Whereas regression is little different. Okay. Coming to the next slide, correlation. What is correlation? Correlation can be many different type. If we just take an assumption that your variables are, means two variables, I'm talking right now about two variables only. Two variables are linearly related, then the correlation becomes very easy. To understand it, this becomes very easy. That is why I have taken an example of a linear relation. Linear relationship means there is a sort of a formulation between your variables x and y for a moment. Okay. Generally, correlation gives us a numeric value, and this numeric value is always between -1 to 1. Okay. Naturally, when you put it on a line, -1 comes on a left-hand side, +1 comes on a right-hand side, and exactly in between there is a 0. If you put it in a line theory, okay. Now I'm trying to connect it with the interpretation part. So when I say our correlation is 0, what do you mean by that? That means there is no correlation between the respective two variables. Whatever the variables are for which you have calculated correlation, there is no correlation. There is no correlation means your value of R. Generally, correlation is being denoted with small r. This value of R goes to 0. Okay. Naturally, I'm taking an extreme point only, so that gives you a clear idea about it. For a moment, let us suppose R is equal to +1. How you will be interpreting it? R is equal to +1, that simply means that there is a perfect relationship between both the variables. I'm taking variables as x and y. Then there is a perfect relationship between x and y. R is equal to plus 1. Okay. Now, focusing on the another extreme, R is equal to minus 1. How you will be interpreting it? Look, I am asking you one question. Can relationship be measured as negative? Relationship cannot be negative. So when I say R is minus 1, that means there are two components. One is minus and the second is 1. A numeric value and the another plus or minus sign defines direction. Direction means when I say R is equal to plus 1, that means it is a perfect relationship and both of them are going in the same direction. If X increases, Y increases. If X decreases, Y decreases. Means they are going hand to hand in a same direction. That is how this correlation becomes plus 1. When I say now coming to the exactly opposite of that, R is equal to it is minus 1. Okay. When I say R is equal to minus 1, what it indicates? It indicates perfect relationship. 1 means perfect relationship for sure. When I say it is minus, what do you mean by that? This minus sign defines direction. That means both of them. The way X is increasing, Y will decrease. If X decreases, Y will increase. This minus sign describes that they are moving in a different direction, going it with the same passion as it was going it with the plus 1. But thing is, they are moving in a different direction. That is the story of this plus and minus. Means whenever this correlation is given to you, always try to put this plus or minus sign in between, right? R is equal to, when it is 0.8, put it like this, the R is plus 0.8. Because that plus defines direction and 0.8 defines yield, or you can say magnitude of correlation. Is it clear? Okay. This is what the story about this correlation is. Okay. Now coming to regression. Correlation always gives you a single number. Single number in the sense it is 0.8 minus 0.75, something like that. A numeric value is showcased. Okay. It is statistics. Statistic in the sense that it will only speak once the event is done on the basis of data. If I just want to, let us suppose your variable x and y, x is time. Time in the sense, let us suppose 10-year data is given to you. Production of sugarcane. Let us take a sugarcane industry or any of the industry. Production of an industry, that data is given to you. That would be in form of tons. And year-wise data is given. So 1990 to 2024 is your variable x, and variable y is, let us suppose it is the production of any of the factory. Fine enough. What will happen? You can get a correlation. And for a moment, let us suppose that correlation is 0.75. You can say it is positively correlated. Okay, positively correlated means plus 0.75. That means both of them are going in the same direction. That indicates that plus sign, and 0.75, which is more than 0.5. So you can say that it is highly positively correlated. Fine enough. That becomes a judgment. Let us suppose 1990 to 2024 data set was given to you. My intention is, on the basis of this data, I want to predict something for the next year. Is it possible with correlation? No, it is not. Correlation only reflects thing which is already done. If I just want to predict it for future, for a moment, let us suppose my data set is available from 1990, and I may have to estimate for something which may happen before 1918, what may have happened in 1989. That is my intention to get a value for it. It is not possible with correlation. That is where this regression comes in picture. Naturally, correlation becomes a single value. When I say regression, it may not be a single value. Now it would be in an equational form. Just pass on data and you will get certain line. Since I call it a linear relationship, so naturally it may come in a form of a line. Means formulation of a line. Y is equal to a plus bx. That is what a general and a standard line formulation is. Okay. So the equation part would be y is equal to a plus bx. I have written triple A here, triple A plus triple B times x. Actually, here thing comes as one more criteria is there, which is called independent and dependent variable. Y is equal to triple A plus triple B times x. It is a linear format, line format. I'm asking you a non-statistical question. Y and x, these are the two different variables, right? Okay. Which one of these two is dependent and which one is independent? When I say y is equal to a plus bx, among this, which one of these two variable x and y is dependent and independent? Look, when I say y is equal to a plus bx, you are allowed to take any value of x. Convincing? You can take any value of x. Okay. On the basis of that value of x, you will get value of y. Because a and b are certain constant values. Okay. That means you have a privilege of taking any value of x. That means your x is independent. You are allowed to take any value. You are allowed to take any value means you are not dependent on anything. That simply indicates that your value of x is independent. Okay. Once you fix the value of x, you will get value of y. So naturally, your value of y becomes dependent on value of x. So your y becomes dependent variable. Right? Generally, if you put it in equational form, y is equal to a plus bx. What is the difference? A is a constant value. Look, there is no variable in it. In B, it is a prefix of a variable. It is B times X. So B is a prefix of a variable. Okay. Uh, uh, Certain mathematical rules are there, or you can say certain mathematics is applied in this case. Since A is a constant value, it is called, if you put it on a graph, it is called intercept. Intercept means two lines where they get intercepting with each other. That intercepting point is your value of A. Then what is the value of B? If you just take a all the data set on a graph paper, and since it is a linear equation, it will generate a line. Slope of that line is your value of B. This is what I said it in a mathematics or in a statistics. Coming back to our part, since you may not be having that exposure of mathematics and statistics, because you may be doing your research in law, you might be doing it with any clinical trials or any your domain may be little different. Simple thing is dependent variable and independent variable things are clear again. Intercept, and I said law. I'm giving you one example. That will make it absolutely clear. Let us suppose our intention is to predict the price of house based on naturally size of house. Size means it can be of 200 square feet, it can be 700 square feet, it can be 1250 square feet. In short, it may vary. On the basis of that, naturally, price may vary. It is as simple as that. Okay. Look, number of square feet, or you can say size of a house, which is in our hand. In our hand, in the sense, in the hand of a builder. And if my budget allows me that, on the basis of that, I'll be taking my decision. My requirement is of 500 square feet, so then this 500 becomes X for me, and the price of the house becomes mine. Okay, coming to that part, right? So this is how price is dependent on the number of square feet, requirement of a square feet. Okay. This is what we talked about. I have tried to conclude it in a single slide uh, about correlation and regression. This is what we exactly talked about, right? So I'm not repeating it again. Simple thing. If you just conclude it, this correlation and regression. Correlation helps us in quantifying the strength and direction of a relation. Whereas while using a regression, we may predict, it is called a predictor. We can predict the future or any of the missing data. But before of that, if we focus on regression, we should be very much clear about uh, its dependency and independency. Which one of these two variables is dependent or an independent, that we should be knowing it in advance, then only we'll be able to use a regression. Right? Okay. And the next thing is locational average and outliers. Okay. Uh, Locational average and outliers, what exactly it is? Locational average means it is a very, you may have used all this terminology, mean, median, mode, many a times. Mean, median, mode. Which one of this is called locational average? And then after, we just want to concentrate on outliers. To go to reach outliers, we should know a little bit about this locational averages, right? Okay, mean, as all of us knows, mean is nothing but total number of whatever may be there. For a moment, let us suppose percentage of a mark sheet. We just make sum of each of the score of all the subjects divided by number of subjects, that gives us mean. Simple. Fine enough. What you can say about median? What we can say about mode? Okay. I'm not sure about Maharashtra, but in Gujarat, the new thing came in picture in the 12th board examination of a Gujarat state. Nowadays, in a mark sheet, there are two things displayed. Earlier, when I was studying at that time, only one thing was there, and which was percentage. Nowadays, there are two parameters reflected in our mark sheet. One is percentage, and second is percentile. Have any of us ever noted that what is this percentile? I'll be very happy if anyone may have focused on it. Focused on it in the sense, what is percentile? In the 12th standard Gujarat board examination, two things are reflected in the mark sheet. One is percentage. First thing, let us focus on percentage because it is coming from an earlier day. Percentage is nothing but we just make a sum of each of the score of subject and divide it with total number of subject, and that gives us percentage. Okay. First question is this arithmetic mean, or you can say a percentage, is sufficient to reflect the performance of a candidate? No, it is not. It is not just because of, for a moment, the example which I have given here is 10, 20, and 30. If we just make a mean of, means arithmetic mean of this 10, 20, and 30, arithmetic mean is 20. Fine enough. Now, I am trying to give it other way out. Instead of 10, 20, and 30, now it is 0, 20, and 40. 0, 20, and 40. Okay. 0, 20, 40. Again, you just make sum of them, divide it with 3. Again, your mean is 20. Look, if you just take a decision, on the basis of that mean 20, what will happen? The performance of both the candidates are same. That is what you are claiming. For a moment, let us suppose 10, 20, and 30, and the another data set is 0, 20, and 40 are the data set of a student scoring in 3 different subjects. Now what will happen? Look, one of the person who is getting mark 0, who is failed, even though on the basis of percentage we are treating them equal. So this mean is not going to suffice the need. This is not sufficient. We may have to insert something more in it. That is where the next thing came in picture, that we call it percentile in our mark sheet. That is nothing but a locational average, where they are located, the location of a person. Median is nothing but exactly 50%. Exactly in the middle of your data set. That is what median is. Means 50% of your data set is left hand side on it, 50% of data is on right hand side of it. If you just put it on a graph paper, that becomes median. Mode is the highest frequent value becomes mode. In a data set, if a number is occurring highest number of times, that becomes mode. As I said it, in a mark sheet, arithmetic mean was not sufficient, so they gave it a percentile. Percentile is nothing but a locational average. Locational average means, again, in this case, median, it is 50-50, whereas you can put it in a percentile form, decile form. There are many different ways. If you just put it in a percentile form, means you are separating your data set in 100 different parts, segregating it in 100 different parts. Okay. Third thing is mode. Okay. When I say mode is the highest frequent value. When I say highest frequent value, why it is needed, when it is needed, that will be the basic question. Okay. The basic question is where this mode is needed. Okay, for a moment, let us suppose you are going to start one of the company, a footwear company, for a moment. Which size of sandal is to be produced? Which size of the sandal is to be produced? How you will take a decision? If we just take it from an arithmetic mean, what is going to happen? Arithmetic mean of a previous data. If you just go to another company and take the data, and if the data 6 numbers sandal, let us suppose 75, 7 number sandal, let us suppose it is 100, 8 number sandal, which is 125. And if you just take a mean of it, which comes somewhere 6.79, Is it possible to have a shoe or a sandal of size 6.79? Practically not possible. Then what one should do? Naturally, in that case, all the averages like mean or a median may not be sufficient. The only thing sufficient is more. So one should be, I'm not going inside of it because it is an undergraduation problems, but I'm putting it in a larger way that every averages may have their own utility values. In a certain case, means are used. In a certain case, even this percentiles are used. In certain case, modes are used. So one have to pick it according to their need, right? Okay. Understanding the central, the only difference among these three is mean. The outliers, whatever may be the outlier, means extreme values. Extreme, your mean is getting affected by extreme values much, much, much more. What I did was, instead of 10, I made it 0. And instead of 30, I added that 10 to that 30, it became 40. The mean remains same. But look, instead the range of the first data set was 10 to 30, and in the second data case, it was 0 to 40. I enlarged the range of a data set, right? I inserted some of the extreme value. So, extreme value, if you just change an extreme value, at that time your mean is getting worst. I mean, it is being affected much, much more. Whereas in locational average, your averages are not getting affected by these extreme values. So that is how that utility value of a locational average is much more compared to arithmetic mean. Okay. Central measure or to understand the central tendency of a data, and it compares data sets or track of changes over time. This is what the outlier is. Outlier simply indicates, let us suppose one of the variable in your experimental design is age of a person, right? Generally, naturally, while taking a data of any of the sample, in that sample, uh, this age may range between certain values, right? Okay. Traditionally, you can say that it may range from 1 to 100. Fine. But while you take a data set, it may not be between 1 to 100. For a moment, let us suppose the data is collected and you ask your data entry operator to feed the data in Excel sheet or in an SPSS browser. Okay. Instead of 50, he wrote 500. What will happen? Age cannot be 500. For sure, there is a mistake. Okay. How you will come to know that this is a mistake? So whenever all the data set, once it is being fed, it is to be purified. Purified means validation. Validation is one of the criteria. Means validating your data, so you have to observe this outliers. Outlier means if you just put it on a graph paper, look, the first thing, which is this is the main part, the thing which is given in the graphical, which is the main part. One is median, one is maximum, one is minimum. Your average may be somewhere in between of this, but over and above, some outliers, it can be on upper hand and it can be at a downward grade even. Okay. This upper and down, one word is used, outlier. They can be a mistake or that can be, one cannot take those outliers until and unless they do have some certain logic behind it. Right? So first thing is to identify these outliners. If you just put it on a graph paper, in a second or so, you will get that outlier. If you allow these outliers to be inside your study, you should have a strong reason behind it. So to identify this outlier, these are the main things, right? In any case, if you are not sure, if you are convinced about that it is a mistake by done by uh, any of your typists or data entry operators, then you can remove it. This process is called purification of a data. Before analyzing, this purification of data set is very much needed. Once you purify it, that means you are validating it, and then after it is ready to fire or ready to use for statistical test. That is why these outlays were required. Okay, if the major part of your points for a moment, Z, if it is greater than 3, Z means it is Z statistics. If it is greater than 3, then you have to drop the entire data set because everything is beyond outlier. Beyond our data means there is a massive problem in your data set. That is for sure. So you have to alter your data set for sure. You cannot analyze it, and in any case, if you analyze it, you will not get a right result on the basis of which you can conclude something. So beware about that, right? Okay. On mean, median, mode, as I said it, mean comes somewhere highest and lowest in between of something. Median is exactly in between. Even mode is between those two things. Right? This is impact of outliers. Relationship between location, this is what we have talked about. Median is exactly the 50% on left hand side, 50% of right hand side, and it is not being influenced by extreme values. Whereas mean is largely affected by the extreme values, the outliers. Okay, this is what the conclusion part of locational average. Central value, that means mean, exactly 50% left right becomes median, and highest frequent value becomes mode. Try to identify the outliers, make a right decision whether to keep it or not to keep it, clean your data set, and then after go for analysis part, right? Ma'am, uh, uh, just
Yes, sir.
shall we have a break of 5-10 minutes,
Yes, sir.
right?
Yes.
Because it becomes little
Announce.
heavier
Yes,
if
yes.
we just go on.
Varuka sir ma'am will announce about the break.
Okay. All the participants, we have 10 minutes break.
Fine.
Please join at sharp 12:30. Sorry, 12:25
12:25 is fine. 12:15. Right now it is
12:25
12:15. We'll
to
be joining
proceed.
again at
Yes.
12:25.
Yes.
Perfectly okay?
What is the agenda for next session, sir?
Fine. Again, we will be continuing it with this, and until and unless it is completed, then after we'll be shifting
Yes,
it.
sir. Continue. Continue.
Okay, sir. Okay, sir.
Thank you so much.
All are requested to join at 12:25 sharp.
Fine.
20.
20.
25
10 सांगितलं.
10 minutes break, man.
10 minutes.
12:25. If I'm
Yes,
right.
10:25.
Okay. Fine.
Yes. Thank you.
Sir, please proceed.
Okay, fine. Thank you once again.
Yes.
Okay, now we'll have it little faster as we want to much focus on the software part also. The next thing is we should be, before proceeding for testing, we should be very much clear about the dependent and independent variable. As we have seen in earlier event, that what is dependent and what is independent. Okay, the dependent variable is outcome or a response. It can be measured, observed, or predicted, right? Okay. It is very simple. Generally, on a graph paper, we take it on a y-axis. The dependent variable in this simple sense, it is the exam performance. For a moment, let us suppose it is a test score. The test score is generally dependent on the number of study hours and the IQ which a person may have. So naturally, it is dependent on that. That is how it can be treated as. Since performance in examination, or you can say a test score, is a dependent variable. So whenever you are defining any of the variable which is dependent or independent, it is to be you should be sure enough before generating that variable. That is what the aspect is, right? Okay, when I say independent variable. Independent variable in the sense which cannot be, you can take any value for it, right? Means it is up to us. How many study hours are to be fixed or to be given to get a good score, that is in our hand. So if it is in our hand, so naturally it is independent. So that is how generally while putting it on a graph paper, we have to take it on a x-axis. So if you just put independent and a dependent variable on a graph paper, then always an independent variable should be put on x-axis, whereas dependent variable is to be kept on y-axis. Generating any of the variable, one should be very clear while generating it that which one of those are dependent and which one of those are independent. Let me give you one simple thumb rule. The thing which you are measuring in the sense of height, weight, a production of a company, or whatever it is, in short, all these are always independent variables. Now, generating cells out of it, naturally, generating a cells of a company which is dependent on the production which you are making. So naturally, that becomes a dependent variable. Clear? Okay. If you just put it as a thumb rule, independent variable are always a sort of a cause. It reflects cause. There is always a cause and effect relationship between variables, right? Okay, if there is a relationship of cause and effect, so always the cause is an independent variable. On the basis of that, effect is being generated, so that effect becomes a dependent variable. One can take it as a thumb rule. Okay. These are the key differences. That is what we talked about. X-axis, Y-axis, predictor, outcome, predictor, or you can say cause, independent variable, effect, dependent variable. These are the key differences. Okay. These are some examples of a different segment or cluster. In medicine, what dose of drug is to be given? It is in doctor's hand. If it is in doctor's hand, naturally it becomes independent variable. On the basis of those dose, if there is a change in blood pressure, then change in blood pressure is an effect. Since it is an effect, it is a dependent variable. Same one can think of in education, in economics, in an environmental science, or whatever domain which you are in, or you have taken a research project in. So you can ask few questions to self, and the answer which you produce will define that your variables are depend which one of the variables you have taken are dependent and which one of them are independent, which is very much needed before starting any of the analysis. Independent variable should be on x-axis, dependent variable should be on the y-axis, and we can take a graphical situation to visualize the relationship. This is what we talked about. Okay, one more thing is there, which is very important before starting analysis of a data. There are two type of tests. One is called parametric test and another one is called non-parametric test. There is a basic difference among these two. The first and the most important difference is we are talking about parametric. Parametric test is to be applied to those for which we assume that our data set is coming from normal distribution. If we are sure about this, our data set is coming from normal distribution, then we have to test, we have to use parametric test. Okay. As I said it earlier that generally all the data set, if it is of a larger form, a huge form of data is there, generally it follows normal distribution. Means that assumption is to be taken off. If you take that assumption, then you can use a parametric test. If you are not sure, sorry, if you are not sure about the distribution of your data set, in that case, in that case, parametric test cannot be used. Okay, if I say parametric tests cannot be used, so there should be a solution for it, and that solution is non-parametric test. So, short of a thumb rule, if you are very sure about your distribution, where data is coming from, if it is normal distribution, use parametric test. If you are not sure about the distribution where your data set is coming from, use non-parametric test. That becomes a thumb rule. It is as simple as that, right? Okay. How you may come to know that your data set follows a normal distribution or not? So there is a sort of a test even, and even if tests are not there, whatever may be your data, if you just try to plot it on a graph paper, if that graph paper, all the points are largely in a bell-shaped form, you can say that it is following normal distribution. If it is not of that bell shape, you can say that it is not following normal distribution. It is that much simple, right? Okay, coming to normal distribution, variances are same, larger sample size and data scale. These are the characteristic of a parametric test. Parametric tests are used only if your data set is normally distribution, there is a homogeneity of variance. Okay. To understand it, let us suppose you are taking.
जनरली आमच्या पण
Kamble ma'am, please mute yourself. Kamble ma'am.
अमृतसर हो आणि 2 जेन्ट्स होते ना तुमच्याकडे
Kamble ma'am.
It's okay. Homogeneity of variance, what exactly it is? For a moment, let us suppose we have gathered the data and one of the variable is gender. So male and female. There can be a variances related to a male members and the aspect of or the involvement of, or you can say the selection process of a male member may be a little different than that of female members because their needs are different. So in that case, variance of male member and variance of female members, if they are same, once almost same, one should not, it should not be that it should match figure to figure. But if they are almost same, in that case, parametric test is allowed. As I said it, normal distribution, if your data set follows normal distribution, parametric tests are advocated. Okay, when a normal distribution, you can make a prediction that it is normally distributed. If your sample size is much, much more, you can take an assumption that it is normally distributed, right? And similarly, if your data is measured in form of interval or a ratio scale, I'm coming to this part in the next slides, what can be the data type or data scale, right? We'll see it in detail in what is this interval or a scale ratio, ratio scale rather. That will come at a later stage. If it is in a form of an interval or a ratio scale, we can use a parametric test for sure. You don't need to ask anyone else. If you are sure about these 4 points, blindly apply parametric test. Example of parametric test, even t-test, z-test, ANOVA, analysis of variance, correlation, regression, all these are the example of parametric tests. Again, when I say that these are the example of parametric test means they are coming from a normal distribution having variances almost equal. They are in a form of an interval or a ratio scale. All this, the thing which we have seen in earlier slide, it follows all those parameters. It is as simple as that, right? Okay. Non-parametric test. In a non-parametric test, data type scales are of 4 types. It can be ordinal, nominal, it can be in interval form or a ratio data. Of which, if it is of ordinal or nominal form, at that time, non-parametric tests are advocated. Okay, it is that you can take it otherwise. In an area where these parametric tests are not allowed or not advocated, at that time, one may have to use non-parametric test. It is simple. If your outliers are much, if your sample size are small, and you are not sure about that it is coming from a normal distribution, then non-parametric tests are advocated. Okay. When it is to be used? For a small sample size, non-normal distribution, ordinal or nominal data set, or an unequal variances, means homogeneity is not there in your data set, one has to use non-parametric tests. Right? So there is a difference. Now you may have understood it quite well. Okay. Now, which are the tests which are called parametric and which are the tests which they are called non-parametric? That is needed now. Okay. Man-Witten U-test, Willickson sign rank test, Kruskal-Wallis, Spearman rank correlation, even a chi-square test which we are using very frequently in any of our research paper or in our PhD thesis. All these are the example of non-parametric test. Right? Okay. One thing. In many of the PhD thesis or in your dissertation, You may have taken some of the variable as satisfaction level, means 5-point Likert scale is used. You analyzing those Likert scale non-parametric test is advocated. Secondly, there are certain areas when the pre and post analysis is done, means giving some treatment before and after. Pre and post means it is before and after to the same group of patients, and we want to evaluate that is there any difference between the behavior pattern of these two groups or not. Behavior pattern in the sense whether the treatment is given which is really it could make certain change or not, it is to be tested. Then Wilson sign rank test is to be applied. Okay, even in NCOA, again one more thing is there. In a parametric, it is called NCOA. That NCOA is used if it is coming from normal distribution, and if it is not, then this Wilcoxon sign rank test it is to be applied. Right. So every test may have their own utility values, but largely we can say if it is not coming from a normal distribution, these are not parametric tests. The only thing comes in your mind should be these are the differences. Apart from these differences, one thing should come in your mind. Which one of these two tests are more appropriate, or you can say more efficient? Naturally, parametric tests are more efficient and you can say more advocated compared to non-parametric test. Fundamental assumption is normal distribution and it is not coming from normal. So when it is not coming from normal, whatever may be the result of non-parametric test, the authenticity by which you say that this is going to happen, it is more in parametric test compared to that of non-parametric test. So always try to use parametric instead of non-parametric in the case. If you don't have option left for parametric, then only use non-parametric, right? And this becomes a thumb rule. In medical research, comparing the mean blood pressure level between two groups, use parametric. Comparison of effectiveness of two drugs based on ranked. In many of the theses or any dissertation, you are using some of the variables in which you ask them to rank 1, 2, 3, 4 on the scale of 1 to 10 for a moment. So this rank is not a short, rank is something very personal, you can say. So naturally, you cannot expect it is coming from a normal distribution. So in that case, one has to use non-parametric test. In education, and ANOVA, against of this ANOVA, Kruskal-Wallis test is non-parametric can be used. In a marketing research, correlation can be used, and if similar kind of a thing is to be tested with non-parametric, then a chi-score is advisable. Right? Okay. As I said it, parametric tests are more powerful, but we have very strict assumptions. Very strict assumption in the sense it is coming from a normal distribution, variances are same, it is from a large sample, and the data set is in a form of interval or a ratio. Whereas non-parametric, if any one of these four assumptions are not there, you don't have anything left other than testing it with non-parametric test. Right? I think this slide may have given you input that how this parametric and non-parametric tests are different. Whatever may be the case, you have to select accordingly. Okay, now we are coming to the the main part. Data type in research. Now we are talking about research is okay. Research in the sense it is a discrete or a continuous type and things are same. But we are more focusing towards now SPSS. In SPSS, how you will be treating your variables. That is important part. Based on nature, qualitative data and naturally quantitative data. Qualitative data, it is of a categorical type. Nominal. Okay. Nominal means you are giving a code. Let us suppose you are asking gender. Gender means male or female. These are the two options. Okay. Statistical analysis can only be done with numerics. One thing is very sure. Statistical analysis can be done only for numerics. So naturally, this gender, male and female, or a blood group, A, B, AB, O, whatever it is, in short, you have to make a code accordingly. You have to give a code. Okay, male and female, if I just want to put it on a paper, I mean, put it on a browser, or data entry operator may have to put it in numerics. Okay, naturally, to put it on in numerics, you may have to code it. Means for a moment, male to reflect male, give code 1. To reflect female, give code 2. Fine enough. Same way, blood group A, B, AB, O. Give 1, 2, 3, and 4. Code. Okay. Look, you are giving a code. But there is no interrelationship between code. 1 means male, 2 means female. That doesn't mean that female is much higher in weightage compared to that of male. There is no weightage system in between. It is simply a code, and that numerics doesn't allow or doesn't make sense as far as yield is concerned. Right? So that type of data set is called nominal data. I'm putting more emphasis on it just because of while entering your data in SPSS browser, this will be the first requirement. Which type of data set is there? That will be the first requirement. Okay. When I say ordinal, again, ordinal means education level, primary, secondary, or graduation, something like this. Okay. Look, these are in sequence. Primary, then after secondary, and then after graduation. So these are in sequence. If you give a code as 1, 2, and 3, 1 means primary. So it is a sort of a yield. Primary means the thing is you can put it as 1, secondary as 2, and third graduation as 3. Satisfaction rating. Very much satisfied, satisfied, neutral, dissatisfied, very much dissatisfied. It is a 5-point Likert scale. So here you can have the coding as 1, 2, 3, 4, and 5. So look, there is a relationship between 1, 2, 3, 4, and 5. There is some aspect behind it. That is how these variables are called ordinal data. Quantitative data, numerical data. If you just classify your data by the behavior pattern of a data, one is called discrete and second is called continuous. Discrete means taking full values. Full values means number of students in a classroom, number of printing mistakes per page, number of accident on a particular road in a particular time span. Look, these examples are the best example of a discrete data which will never reflect fractional number of kids per family, which is never going to be 3.5. I'm getting my point. In short, how you will be, if you just go deep inside it, how you will be knowing it that it is a discrete data. That is a thumb rule. Let me ask you one question. In your class, let us suppose 50 students are there, and someone asks, how many students are there in a classroom? What will you do? You will count 1, 2, 3, 4, something like that, right? Number of accident on a particular road, again 1, 2, 3, 4. Number of printing mistake per page, again 1, 2, 3, 4. Look, anything which is countable in the sense you have to count it to give your answer, which becomes base of discrete variable. Always your counting starts with 1 and it goes up to certain level. So any variable where you start it with a numerics 1 and you just go on counting, means counting process always reflects discrete variable. Think of continuous now. In a continuous variable, temperature, height, weight, look, temperature, height, weight. Is there anything common among these variables? Yes. Everything is to be measured. Temperature, measurement, height, measurement, weight, measurement. The base is measurement. Any variable which are being measured always reflects continuous variable. It is as simple as that. Right? So if you just classify your data with quantitative way, numerical data, then it can be of this type. Okay, again coming back to nominal data categorized, a natural order, as I say, eye color, blue, green, brown. It has nothing to do with weight. If you just put it 1, 2, and 3, naturally, there is no connection between 1, 2, and 3. It becomes nominal. If you just say survey rating, it is poor, average, good, excellent. So look, poor, average, good, excellent, they are in hierarchy. Since that hierarchy is to be reflected, one can make a coding as 1, 2, 3, and 4. So naturally, there is a relationship. So that is to be treated as ordinal scale. Third is interval scale. Interval means that again a continuous variable. There is a lower limit, there is a upper limit, and a value means a variable can take any value between those two limits. So that is called an interval scale. So continuous variable is to be treated as an interval scale. Ratio scale, naturally, always something upon something, which reflects ratio. Particularly, these variables are used in financial implication. In company data, if financial figures are there, they use ratio scale much more compared to anywhere else, right? If it is always in a form of a ratio, and you are sure about that denominator is not zero at any point of time, then one can take it as a ratio scale, right? Okay. Collection of data, where it is coming from. On the basis of that, if you just classify your data, it can be primary data and secondary data. If you are collecting your data using questionnaire, means directly a unique person is filling your questionnaire, it is called a primary data. Then what is called secondary data? The large form of a primary data means you have privilege that whatever data set you need, you can ask it in form of a questionnaire and people can fill it and give it to you. It's whatever is needed that can be designed and that can be treated as a questionnaire. What happens with the secondary data? Secondary data means government normally produces all agricultural data, historical data, all this data are shown in some of the reports. For a moment, let us suppose MSME companies. The MSME, what are the turnover of all the MSME companies? So government may have done work on it and they may have produced certain reports and you are using those data directly from some reports. So that becomes secondary data for you. It is not a primary data. What is the difference among these two? In a secondary data, whatever is available from which you have to use it. Whereas in the primary data, what is going to happen that you may design your own questionnaire, whatever is needed, you can frame it and you can get that data. These are the two basic differences between primary and secondary data. Though equally it is important, but in secondary data, whatever available at the source means it is on a government portal or in some of the report, whatever frame it is available, you have to use it. Whereas with primary data, you can have your own frame, right? Okay. Cross-sectional data, data collected at a single point of time. Income level of a household in a city can be treated as cross-sectional. Student test scores on a specific date. Look, here one more parameter is inserted, which is time. It is in accordance to time. If time is being treated as one of the parameters, those data set is called cross-sectional data. Longitudinal data. Generally, time, but for over a year, over a decade, over a century, meant if the time is much, much more, and second, it is geographically, means instead of one city, now it may be for state, it may be for country, it may be for number of states. In that case, it may be treated as longitudinal data set, right? Okay. Choice of a data set, a statistical test. This is again important. Parametric test requires interval or a ratio data. Non-parametric, again, as I said, it ordinal, nominal type of a data. Visualization. Visualization means graph. Whenever you are using a graph, at that time pie charts are used generally. Generally, it is used for nominal data, whereas histograms are used for continuous data. Right? Okay. This is what we have seen, and we can conclude it this way. Understanding data type is very much needed, and which is probably the first step towards analyzing the data. This was all about, you can say, the statistical part of it, right? Now, we just want to switch over to SPSS now. Just give me a minute. Okay. As we are running little short with time, I'm directly coming to the menu part. Is it visible? Hello?
Yes, sir.
Is screen visible?
Yes, yes, yes.
Okay. Is it perfectly okay?
Okay, sir.
I mean,
झूम करायला हवी का सर?
just a
सर
minute.
झूम
Just a minute. I'm doing it.
सॉरी मराठीत सांगितलं.
I'm having problem with Marathi. As such, basically, I am from Nagpur. But at that time, I was a little kid. So at that point of time, I was aware of this language quite well.
Sorry. If you make it zoom, sir, it will be the large image for
Facing
all of
to-
us.
Okay. Okay. Just give me a minute.
Yes, sir.
Okay. Mm, Just a minute, ma'am. I'm finding it little some error in it. Is it there, ma'am?
Yes, sir. Now it is properly visible.
Now it is fine?
Yes.
Okay. Fine. It is divided in 2-3 different parts. So one after another, I'll be doing it, right? Okay. I have skipped one part, which is how to start SPSS. It is simply there is an icon which one can make a press and they will get to be inside the SPSS. The first screen, how it may look alike, it would be like this. Just observe it. There is a data set, the name of a file. Naturally, we haven't given any name, so it will be treated as an untitled. In our very next line, there would be a sort of a menu will be there. Some of the icons are there, right? Okay. One after another, how this is to be done. This is called a menu. In menu, there are different options: file, edit, view, data, transfer. Haji? Hello? Am I audible?
Yes, sir.
Actually, I heard some noise.
Yes, sir.
Okay, fine enough. Thank you. While clicking on any of this menu part, we'll be able to see the options. Fine. It is as same as you don't have to bother much about this SPSS just because of it is as same as of any of the Word, Excel, PowerPoint, Excel which you are using in a day-to-day, everyday life. It is that simple, right? There would be a new file opening, opening a file, closing a file, saving as, save all data. I mean, all these options will be there. Similarly, you may have another option of edit. Editing a file is being done with an edit menu, viewing it with a different criteria that can be done that can be treated as taking a selection from a view data set, data, defining variable properties, and everything else can be thought, everything can be done using the option menu data. Transform. Many a times it may be needed that we have to calculate certain variable, recode certain variable, recode with a from a variable, and another variable is to be defined, which is nothing but a recoding of the previous one. That can be done. Means it is a transformation. Means this transformation can be done using an option menu of transform. Very important, and the thing which we are using more and more is analysis. This is a very important option for us. In this, there are many different options, of which one of them is this descriptive data. Descriptive statistics means if you just want to know the frequency of your variable, whatever you may have defined, all the frequency. Second, mean, its median, its mode, its standard deviation, all these things can be calculated with this descriptive statistics. The another option very important for us to start up and any of the analysis is compare min. There may be different options with compare means even. Compare means a t-test is to be used, z-test is to be used, with many other pairwise t-tests is to be used. All this thing comes under this comparing the mean. Similarly, general linear model, correlation, and regression can be done by selecting this option. There are plenty of options, but right now we are focusing on the elementary thing, and that is why I have tried to restrict it on the limited options. Direct marketing. Direct marketing is one very another thing. Which technique is to be used? We can put that technique here and we can proceed with it. Graph. With a graph menu, there are many different options available like bar chart, line chart, pie chart, box plot. Box plot, you might be remembering it. In an out layer in our presentation, we kept that box plot from which you can get those outliers. So that can be, all the graphs can be done using an option menu of graph. All these are utility values. Utility in the sense it is, you can say, back of the curtain processes, all these utilities. Add-on. Add-on is something in SPSS nowadays, only the elementary options are given to you as far as analysis is concerned. And if you want to use MOs or a structural analysis, then you have to purchase those add-on facilities from SPSS, and those things are kept in this particular menu option. Windows minimizing, one can open more than one file, and all the files will be given here, which will be shown here. In the larger way, if you make any of the analysis, uh, output of those analysis will be shown in an output file. So your data file will not be altered at all. It will remain as it is. It will remain intact. Whereas an output file will be generated for each of the output. And during this entire journey, if you need certain help at that time, or tutorials are needed, or a coach, statistics coach is there, if you are stuck somewhere and if you don't know what to do and how to do, you can ask to, you can go through tutorial, and even if your answers are not in tutorial, then statistics coach is there. And if you are online and you have an official version of SPSS, then people, means the person who is sitting across the table, they may help you to get your data analyzed, and they will explain it in any case if it is needed for you. So this is what the first part is. Uh, all the options given in an option menu, and this many different options are there. Right now, what we are doing right now is I have made a platform of SPSS 22. Nowadays, in market, 28 onwards versions are available of SPSS. So there might be little change. In any case, if you download SPSS from its company's portal itself, and for any of the student it is free, you can make it download. If you just download it as a student version is possible to download it. You just download it, all your requirements get fulfills out of it. So you don't have to worry much about it. You can use it. Okay. Once you use it, you will come across all. There might be little change as 22 and 28. There are 4 or 5 different versions they have gone through. So it is possible there might be little change in the options and number of options in an option manner. So this is how it may look alike. I am going to the another file of it. This is very important. As I said, you should be very clear about what exactly the data set you are entering into. Okay. There are 2 type of views available with it. One is called data view and second is called variable view. Variable is to be defined before entering data inside it. Okay, what would be the variable view or how it may look alike? Variable view. Okay, variable view may be looking like this. The first thing is you have to define the name, then after it is type, width, decimal, label, and this many options are there. One has to go one after another. First thing is give a name of a variable. Generally, name of a variable is given in a frame of naturally. If you are entering the data of gender, so naturally the variable name should be gender. Okay, as I said it gender, again, while taking a name of a variable at that time, you should be clear enough that what can be the type of this variable. Okay, as I said it earlier in the presentation that gender, naturally it can be male or female. Okay, male, female, it should be treated in a form of numerics. Then only one can make it entered with SPSS or with Excel. Okay, so naturally here the type of a variable should be numeric. When you put it numeric at that time, what width you require and decimal places, how many decimal places will be there? that you have to define. That will give the length, prescribed length of that variable. Okay. If your variable is of type string, string means non-numeric. Non-numeric means alphabetic or alphanumeric. If your data set is of type string, then alphabetic or alphanumeric things are allowed as a variable. Okay. Once this is done, click OK. Then the next one, width. Width means the length of a variable, right? Okay. How many digits can be there? How many digits in the sense? For a moment, what you're talking about, the turnover of a company. The turnover of a company, if it is coming in lakhs, if it is coming in crores, then you have to make a length accordingly. In this case, as we know that the numerics are there, but in numerics again, we are putting it in a code, 1 or 2, means it is a single digit program. No decimal will be there. So you can put 0 here. That is possible. Right? Okay. Labels are the thing which will be displayed. Whatever may be the name of your variable, which is working behind the curtain. What you wish to be shown in your output file, that becomes the label of that variable, right? Okay. Naturally, gender will remain gender. Most important thing, which is the next part, is value. Since you have given a code, so that code is to be defined here. Values. 1 means male, 2 means female. You have given the code. Naturally, if you have given the code, it should not be up to you only. When you are entering your data set, it is to be shown inside the variable view. So here you have to put it the values. Value. Again, 1, here you have to write it. 1 for male member. Okay, means add. 2 for female. Again, you have to add. And then after, you have to click OK. Any missing values are there or not? If there are no missing values, you can go further. I mean, you can go ahead. Discrete missing values, you have to go ahead, or you can put it OK. Generally, missings are, generally all the missing values we treat it as an outlier and we kept it aside. We keep it aside in the sense we don't take it in our analysis at all. Columns. The column cell is how wide the column should be for each of the variables. That means width of a column. Naturally, if this width is 8, so naturally you should keep the width, the alignment. Generally, the rupees are rightly aligned. There are certain variables which are aligned on left hand side. There are certain things which are aligned on the central part. It depends on your availability. The next thing which is most important is that we had talked earlier, type. Is it nominal? Is it ordinal? Or it is scale? Scale means ratio, or you can say any continuous variable. Here, for every variable, you have to give that which type of variable it is. Scale, ordinal, or nominal, right? Once you select any one of this, what you can say about gender? Gender is of nominal type. Nominal means 1 and 2, where there is no relationship between 1 and 2, so it is treated as the variable nominal. Okay. Another variable, height, and you can put it accordingly. You can give a label, height of a participant. Okay, height, which is measured. So the type of a data should be scale. Weight, again, weight, give a label, weight of a participant. What type of variable it would be? Again, it would be of scale. Okay. Once you define all these variables, we have taken 3 variables only, right? Then after, we have to shift it to data view. Here you will be able to see that, look, the title of the columns are gender, height, and weight. Okay. Here you have to write now. Okay. In gender, naturally, it is of a nominal type. 1 or 2 should be treated. Height and weight are numerics which are being measured. Whatever it may be, it should be, you have to enter everything. This is entry of your data. As many as number of data set is there, you have to enter it. This is almost similar to any of the Excel sheet. While entering data in Excel sheet, almost same things are there. But in Excel, the data sets were not being predefined, whereas in SPSS, everything is to be defined perfectly. Okay. Now, to have a view, value labels. There is a toggle key here. Toggle keys, look, the gender, male, female, 1 or 2, means using this toggle key, you can make a change. You can make a change in the sense, just a minute. Using this toggle key, you can make a change. Look, I am pressing a toggle key. 1, 2, 1, 1, 1, 2. Again, if I use this toggle key, again that will change to male and female. So if you want to check the possibilities, means check the things which are okay or not, you can use this toggle key. Now, after entering the whole data set, it needs to be saved. Before leaving the whole browser, you must save your data somewhere else. Right? This was the thing related to adding a data. Now we are focusing on descriptive type of it. Descriptive state. I'm coming directly to the analysis part now. In the analysis part, the first thing was descriptive state, right? Okay. I have taken one data set, a random data set rather. Several variables are taken. Some of them are gender, ID number, and all data sets are taken, right? This is ID number. ID numbers are generally of a discrete type, 1 onwards, so it would be treated as discrete. Since it is discrete, no points are there. Gender. Gender is nominal, 1 and 2. Same is the case with efficiency. Again, it is of a type, nominal, categorized variable. Enjoyment, cool network, 1 to 5. Naturally, again, it is 1 to 5. 1 to 5. It can be any one of those two, ordinal or nominal, what it should be. Actually, it should be ordinal because there is a link up between 1, 2, 3, 4, and 5. Respect, numerical value, questionnaire. It should be an interval value. It can be taken as a It can take even a point value, continuous variable, possible, respect to. Again, it is an interval variable. It can take point value, but here it is not taking it. Right? Okay. This is how these variables are given to you. Okay. Now, we just want to do an analysis. So actually, we have to click analysis. We want to do a descriptive statistics that are needed. We have to select descriptive state, of which descriptives are to be thought of. Look, here things are very clear. All the variables, and there are pictorial signs on the left hand side of it. Pictorial sign means a scale is given, so it would be a scale variable. Are you remember? In short, nominal, ordinal, all these things may have their own criteria. Generally, gender is nominal. So nominal are being treated with these three pies, right? Similarly, ethnicity is again of type nominal, ordinal, and these are of type scale. Select one of the variable for which your descriptives are needed. You have to select it. These arrows are to be clicked, and you may see it somewhere here on right hand side. Respect. It is a variable which is of type scale. Scale is shown, so it is of type scale. If I just want it on right hand side for which a descriptive statistics is to be calculated, we have to take this variable from left hand side to right hand side. Another variable from left hand side to right hand side. From left hand side to right hand side. Now, this were the three different variables for which we needed to get a descriptive statistics. What are the options available? Look, mean, standard deviation, minimum, maximum, variance. SE means it is standard error. Distribution, its skewness, curiosities, all these things are possible. When you say range, range means it is nothing but maximum minus minimum. That will give you a range. Then just click continue. You will be back to the previous one. And here, if you just click OK, an output window will come out. And this output window, everything you ask for will be displayed. Just observe left hand side. The thing which you have defined as a variable name, as a label, that will be shown in the first column. The number of observation, n is nothing but it is number of observation. Range is nothing but maximum minus minimum. That will be the range of your data. What is the mean of your data set and what is the standard deviation of your data set? All these things will be displayed, and this can be treated wherever it is required. Means you can use it in further analysis. This is variable. It is value of variable. This is n. N means it is number of participants. Range, maximum minus minimum. This shows minimum. value which you have entered, maximum value which we have entered. Minimum to maximum means it will make sum of each of them and divide it by number of participants. That means 50. That will give you mean. And a standard deviation is shown. Right? Okay. Now, the important part is interpretation. Look, the mean of what you are taking, I mean, respect for the right of the others before the intervention. On average, pupil means students. Students seem to enjoy the linking school project with a mean enjoyment score of 3.74. What we are talking about this part, right? Okay. With the standard deviation 1.14. 1.4 is nothing but it is a rounding off of 1.139, right? This is how you can report. But after getting this tabulated format, you have to write it in your own way, in your own system. So this is how you can make a reporting. This is how one can make its interpretation. Okay. In addition, participants' respect score before taking part in the project appeared lower. Mean is 71. Standard deviation is 13.60. Then afterward is 79.44 and 11.702. Okay, what it indicates? It is very simple that after taking part in project, participants' respect increased. That becomes a statement, and that statement is, you can write it this way. This is how you can report it. Okay. One thing I would like to suggest would be, whenever you are writing mean, at that time standard deviation should be written with mean, because only mean is not sufficient. Only mean is not sufficient. Always it should be with standard deviation. Then only it will give you a clear idea about what exactly it is. Right? This is what the option we have taken: analyze, descriptive statistics, frequency, which will give you a frequency. Descriptive and explore, which will explore more about the variables. Once you download this software, you can have an idea of, okay, graph, how one can draw. I'm moving little faster, but things are very simple. So allow me to move little faster as we are running short with time. Deciding what type of graph to produce, interval data and ordinal data, nominal data, you have few options, whereas you have few more options with other type of data set, right? Okay. Different ethnic group, nominal data. Let us start. Pie chart. Take an option of graph, chart builder. You will have to select it. If you don't wish to write this, don't show this again. Then after, okay. Here you will have different options, right? Which type of graph you wish. The variable list is displayed on left hand side. You have to select some of the variables from left to right. The chart preview, the preview is given first, and then after it will be shown in your output file. Which graph is needed, that one has to select it from this part. For a moment, our intention is for pie chart. So naturally, pie chart is to be selected from here. Pie. Okay. Here you have to take this one this way. Okay. Now this and this. These are the variables. You have to drag it from left hand side to this part. And once you drag it, you will have the graph accordingly. Right? Drag it, put it on here naturally. The another variable is needed, which is count. Naturally, number of participant is your count. This is what the primary preview is there. You just click OK. That graph will be shown in your output file. Right? Everything is prefixed here. The color they will select of their own, and the person even you can ask for percentage even. What percentage of data is of this yellow color? What percentage is of this red color? That is possible. You can make a labeling. Again, chart builder. Now let us try something else. Select the histogram now. Histogram. Naturally, histogram is possible for another type of a variable. So you should be clear enough. Histogram selected, put it here. The whole thing changed. Participant and a histogram. I just want to change the variable now. Possible. On x-axis, just take another thing. Naturally, your graph will change accordingly. If you want to show the percentage, it is possible. Instead of count, if you just take percentage here, then they will show it percentage. Apply. Click OK. Look, this is what the graph is. Back to the chart builder. We want to have a bar chart. Bar chart are generally for nominal type of a data. Okay. You have to take away the variables which are of type interval. Gender, nominal, male and female. Now there are two variables. Display. Error means standard error. You just select standard error. Apply. They will show the standard error too. And this will be the treated. This will be the graph of male and female with the standard error. One can have more than two variables in it. both the variables. Put it on y-axis. Click on OK. It will show you both the variables. This was related to graph. Now, chi-square, one of the test. Chi-square is now you should remember it, chi-square is a non-parametric test. How this non-parametric test can be thought of? Gender and text outcome, right? How you'll be calculating or analyzing this. This is gender, naturally 1, 2, and 1, 2, pass or fail. Look, both the variables are of type nominal. Since it is nominal, naturally, you cannot say anything about its distribution. So it is to be treated as, you just toggle it, you will have pass and fail, male, female, something like that. If this go on again, it will check it out. So in this case, naturally, all other tests, T test, Z test, ANOVA, NCOVA, these are not tests to be applied for. So naturally, it is to be applied as one can have a non-parametric test. And the best non-parametric test or an initial test is chi-square. Descriptive statistics, you just use cross tab. Both the variables are of type nominal. You have to select it. You have to think of it whether it should be shown in a form of a row or a column, that you have a liberty. So that is possible. Row. This can be column. What are the statistics should be shown? So here, if you just select chi-square, the chi-square test will be applied. Use continue. Cells. Observed, expected, because in a chi-square test, observed minus expected, square upon observed minus expected. So you have to clearly indicate that these are the observed variable and these are the expected variable. Expected. The percentage of row, column, and total, it is to be displayed. Once use continue and OK. This will be the output of chi-square test. In a chi-square test, what are the counts? What are the expected count? What are the percentage? And ultimately, for male member, for female member, everything is clearly shown in the output table. From this output table, you will come to know almost everything. How it is to be interpreted, which is the most important thing. This table says what it says. In this case, male member failed, number of male member failed are 13, which is 65% of the total in a driving test. Passed 7, which is 35% in male community. In a female community, n is equal to 12 who passed, n is equal to 8 who failed. Those who passed is 60%, and those who fail, they are 40% of the female community. And if you just merge this two, both the things, then what is the case? Even that is shown in the third thing, which is named as total. This is how this table is to be interpreted. Expected value is less than 5, then it will be kept away. In a chi-square, this is a general observation. If your expected value is less than 5, it will take it away. Okay. This is the value. This is the test. Pearson chi-square test value is 2.506. Okay. Degrees of freedom. Degrees of freedom means how many variable, how many options were there in a variable? In a nominal variable, male, female, whatever, then there are two options. -1 means how many comparisons are possible. So always it is n minus 1. So there were two options, -1 becomes 1. So degree of freedom would always be 1. If it is a two-tailed test, we have seen it. What is two-tailed test and what is a one-tailed test? If it is a two-tailed test, then the value, two-sided value would be 0.113. Exact one-sided test, the value would be 0.102. These are the values which is important and which are to be, from which you can get the interpretation, and that interpretation is very much needed. Look, this is 113. Asymmetric significance, two-sided, p-value. If the value is smaller than 0.05, then we can claim that there is likely to be an association between the variables. If it is greater than 0.05, then we cannot make this claim. So this value is 0.113. 0.113 is larger than 0.05. And actually, we cannot make claim that these two variables are associated with each other. Degrees of freedom. How many comparisons you can make? That comparisons are generally n minus 1. Number of variable in a type of variable. There are two options, 1 and 2, one for male and female, something like that. In course, there are only two possibilities, right? How many comparison can take place? It is n minus 1, 2 minus 1, it is 1. That is where degree of freedom is 1. This is the value of a chi-square which they have calculated. A Pearson's chi-square is a name. How it is to be written? One should always write it like this. 2.506 is the value of chi-square in a bracket, degree of freedom, and its p-value. P-value is 0.113, from which you will come to know that whether this hypothesis, is there any significant relationship between gender and driving test or not? That is your hypothesis, right? So whether it is accepted or rejected, we can come to know from this part. 0.113, which is greater than 0.05. Okay. Then what can be the decision? Rejecting the null hypothesis. Right? This was something about chi-square. Ma'am, Uh, Hello.
Yes, sir.
Ma'am, can we keep it up to this?
Okay, sir, fine.
Right?
Yes.
This was all the test which we were talking about was uh, it is for beginners. This was the primary requirement. I mean, the primary tests were this much.
Are
In any case, if we wish, we can have another next level SPSS, and there are three levels of it. One is beginner, second is intermediate, and third is advanced. In any case, if it is needed, let me know. We'll have another session for the next level of SPSS.
Sure, sir, we will let you know.
Fine, enough, ma'am. I think all of you might have enjoyed it.
Okay.
And I'm very happy, ma'am. You were there right from the beginning up to the end. I hope I could generate some interest for every one of you.
You have explained it very simple and soft language, which is very useful for our all participants.
And ma'am, I would like to add one more thing that anyone who was there in this session, and if they wish, they can contact me, but through your domain. Through your domain, in the sense, if they are stuck somewhere in their research area and they need certain help, you just take all the things from them, and then after you just pass it to me. I will try to answer them, and I will help them out with all my capacity.
Could you please provide these videos so that it will help to our participant?
Fine enough. I'll be sending it through mail. Is it fine?
Yes, yes.
And I'll be sending its PDF too. So all the explanation in video, you should be keen enough that what is written here, what is written there. I'll be giving you PDF even, so things will be clear for them. I'll be sharing it all of them.
Okay, sir. Thank you, sir.
Okay,
For
thank you.
such a informative and engaging session, you have helped us to understand not only the capabilities of SPSS, but also how it simplifies the complex data analysis and making it an essential tool for every researchers. Now the session is open for question answer.
Yes.
If you have any doubt, please feel free to ask, or you can post your queries in chat box also.
Fine.
Any question? Everything is understood, sir.
There are two possibilities. I am a man of probability and statistics. There are two cases. या तो सब कुछ समझ में आ गया है, then there is no question. या कुछ भी समझ में नहीं आया है, then
first possibility है.
On a lighter note, it can be any one of these two possibilities.
Yes. Moving to last session, that is vote of thanks. On behalf of Yashwantrao Chavan Maharashtra Open University, I sincerely thanks to Harish sir for his valuable session on the use of SPSS software. Your insights were highly informative and useful, sir. I extend my heartfelt gratitude to our Vice Chancellor, Professor Sanjeev Sonone, sir, for his guidance and encouragement in organizing this workshop. I special thanks to Professor Kavita Salunke ma'am for her constant support and efforts in making this event possible. Lastly, I thank all the participants and organizing team for their active involvement and cooperation. Thank you all for making this workshop a success. Thank you. Have a good day.
Thank you.
Thank you so much, and all the technical team and all of you. Thank you so much.
Okay, thank you, sir. Thank you.